x that changes, variable what? Terms. Because they have the value of x whose values changes. Now, any parameter that you put in front of variable is called coefficient. So this s square, the coefficients of s square is a, that is plus a. For the x here, the coefficient is plus b, that is the coefficient of s square. So I want you to take note of this. And because we are having three terms being connected together, quadratic equation or quadratic function can be called trinomial. Trinomial. So we can call it trinomial. So quadratic function or quadratic equation is trinomial. Trinomial in the sense that it has three terms connected together. Now another question is this. You will wonder, why is it that quadratic equation or quadratic function are expressed like this? How do we come about this expression? I will show us now. Look at what I want to do. You know that square or rectangle, they has four sides. So let me consider rectangle. Rectangle has four sides. Let's say the side that we have here is x minus, let's say alpha. And the side that we have here is x minus, let's say beta. X is the variable there, alpha, beta, they are constants. So let's say the area of this rectangle is the function of this x. What I mean by that is that the value of this area, whether the area will be very big or small, is dependent on what the value of x we take. Because in each of the cases, the value of alpha and beta will remain the same. What I mean by that is, if I have something like this, 3x minus 3, then let's say x plus 2. This particular area, the value of it depends on the value of x. Meanwhile, minus 3 and 2, they are constant. That's what I'm trying to say here. Now, if I want to find the area of a rectangle, generally, is length times breadth. The length is the longest side, so this is the length, and the breadth is the shortest side. This is the breadth, x minus beta. Length is x minus alpha. So in a nutshell, the area, which is the function of x, is given as this times this. That is x minus alpha times x minus beta. Now, I can have a of x is equal to, by opening this bracket, use this x to multiply this bracket here first, then we use minus half to multiply this bracket. That's how to open this particular bracket. So I'm starting with this x, then I will use minus alpha to open this bracket. Let's start with x. X times bracket. So you put whatever that's inside bracket there. You now say minus half times bracket. Minus half times whatever that is inside this bracket. So we open x times x from the law of indices. This is power 1, power 1. From law of indices, when you are multiplying, add the power. That is s squared. Minus x times beta will be minus x beta. Minus alpha times a will give us alpha x. Minus times minus give us plus. Alpha times beta give us alpha beta. Now, I can rearrange what is here because x is common. Minus x is common, so I can take minus x out. So I can have this area which is function of this as a s squared, factorizing minus x out. It will leave me with b. Factorizing minus x out will give me with plus alpha, then plus alpha beta. So now, this one now can be written as s squared. I want to take my x to this other side there. So I have minus, rearrange this, what is here, from the law of commutative law of addition. It's same as alpha plus beta, then times x, then you say plus alpha beta. Now, if I represent, so what I have here now, I can, this particular a function of x, I can write it as a f of x. So what we have here now is a quadratic function. Quadratic function. You can see that the highest power of quadratic function, according to our workings now, we have proved it to be 2. Now, what I want to do now is this. When this f of x becomes 0, then this alpha, this constants that we are starting with, this particular constant, alpha, beta, they are called roots of quadratic equation. They are called roots of quadratic equation. So take note of this now. Let me rewrite. When f of x is equal to 0, this will become x squared minus alpha plus beta x plus alpha beta is equal to 0. So to remember this expression, just say quadratic equation is x squared minus sum of roots. Sum simply means this addition, x, then you now say plus product of roots is equal to 0. Product means alpha times beta. So this is one expression for quadratic equation. Now, if we now have ax squared plus bx plus c is equal to 0. Now, how do we remember this? Another way to write quadratic equation is this. You remember in your English alphabet, we have alphabet A, B, C. So the first three alphabets in your English, are alphabet A, B, and C. Just say is equal to 0. Then put plus in between, plus. Then because our quadratic function that I've derived here, the highest power of it is 2. So you just put x raised to power 2 here. Then you write it in descending order of power of x, which is 1. After 2 you have 1, then there is nothing here. So this will be x raised to power 2. Then this will be x raised to power this is x raised to power 1, from 2 to 1, then from 1 to 0. And you know that anything raised to power 0 is 1. So I can have this as ax squared plus bx plus c is equal to 0. You can see that the coefficient of x squared that I have here is a, but the coefficient of x squared that I have here is 1. So for me to have 1 here, you divide through by a. So we have ax squared divided by a plus bx divided by a plus c divided by a is equal to 0 divided by a. A cancel a. You have x squared plus bx all over a plus c all over a. Anything divided by 0 is equal to 0. Now, I want to now correlate what I have here, this expression I have here. I want to look like this expression that I have here. What do? You know that this one has minus, this one has plus for the coefficient of x here. This one is plus. So I will rewrite this plus to show minus. Look at what I want to do now. I will write it as x squared minus brackets minus b all over ax, because I have to separate my x out. So you can see minus times minus gives us plus. So we see this and this now is same than what we have here. Then we now say plus c all over a is equal to 0. Now in this case now, if I compare now this comparison, x squared go with x squared, minus go with minus, alpha plus beta, you can see. So that means alpha plus beta is equal to minus b all over a. Then alpha beta go with c. So alpha beta is equal to c all over a. You can see now. So now let's quickly solve a problem. Let's quickly solve a problem. The question is this. Given 3x squared minus x plus 5 is equal to 0. Find sum of fruit. Then that's question 1. Question 2 say product of fruit. How do we do that? Now, like the expression I obtained for you the other time, I said the best way to write that expression, but before we can solve this problem, always make the coefficient of x squared 1. So here now, to be able to get 1 here, divide through by whatever that is here. Here in this case is 3. So divide this equation through by 3. So we have 3x squared minus x plus 5 is equal to 0. So we divide this by 3, divide this by 3, divide this by 3, divide this by 3. 3 cancel 3. So we have x squared minus x all over 3 plus 5 all over 3 is equal to 0 divided by 3 is 0. Now, the first formula for the quadratic equation that I obtained the other time, I say x squared minus, you say sum of fruit. You now say x, you now say plus product. Product of fruit is equal to 0. So you can now write that x squared minus sum of fruit means alpha plus beta inside bracket, please. Now say x, then say plus alpha beta is equal to 0. Now, if you compare what I have here with this now, s square go with s square, minus go with minus. Alpha plus beta s go with x all over 3. Or I can say minus x all over 3 go with minus alpha plus beta. So I can rewrite this and this, equate them together. That's minus x all over 3 is equal to minus alpha plus beta x. Now, x is on both sides of the equation. They cancel out. Then minus is on both sides of the equation, they cancel out. So I'm left with 1 over 3 is equal to alpha plus beta, which is the sum of roots of that quadratic equation. Now, to obtain the product of roots, you know, we compare this alpha plus alpha beta with this plus 5 over 3. So you say plus alpha beta is equal to plus 5 all over 3. So this is the product of roots. So we are going to solve some problem. This particular problem, factorize and hence find the root of f of x this, g of x this, h of x this. You can see that the functions changes. When the function changes, the way x will behave will be quite different. You can see now the way x is behaving are quite different from each other. That's why f of x is different from g of x, is different from h of x. So in my next video, I'm going to solve this problem. So please, you can click on the next video for us to solve this problem. Once again, please, this is Orekoya Olusegun, Physics Mathematics Fundamental on YouTube. I'm happy having you around. Please do not forget to like, share, subscribe, and click on the notification button to have more of my video. Have a nice day. Bye.